4.2a lesson using a new technique to solve systems known as elimination. This will be the third technique. We started with one option to solve a system was graphing. Another way to solve a system was to use substitution. And then a third option is elimination. With elimination, what we want is equations that are in something that resembles standard form with the variables lined up, ideally with the variables on the same side and the constants on the other. And we are looking to add equations to eliminate a variable. And when we add these, we notice we get 7x plus 0y equals 4 plus 10 is 14. So we have an equation that is 7x equals 14 because when we add the equations together, it eliminates a variable. And we will finish solving for x by dividing both sides by 7, and we get x equals 2. Next, we're going to take this and plug it back into one of the two starting equations to get our other answer. So we have 3 times 2 minus 2y equals 4. 6 minus 2y equals 4. And we write our answer as an ordered pair again. It doesn't matter which one we plug it back into, but you can see that in order to get the other half of the answer, it does take a little more time than substitution because you actually need to do some solving to get the other variable. Number 3, we have our equations already with x's and y's and constants lined up, and we want to eliminate. If we were to add these, though, x and x would be 2x, y and 2y would be 3y, so nothing would eliminate. So what we're going to do is we're going to multiply one or both equations by something to get a new equation so that variables do cancel. So we'll take the top equation and we'll multiply by -1 because that would give us negative y minus y equals negative 18. And then when we add the equations, negative x plus x is no x's, negative y plus 2y is y, and negative 18 plus 25 is 7. And well, that was pretty quick. And then we take this and we plug it back into any of the equations, even the new one, but probably easiest to plug it back into one of the originals. And we write our answer as an ordered pair. So we can multiply one or both equations by anything such that we can add up the equations and get a variable to eliminate. I do prefer, like I showed in these two, personally, to add equations versus subtracting equations, as I feel like that's prone to errors. So if I notice that I need opposites versus subtract, I'll just multiply by a negative. Look at a couple more examples. Number 6, same idea. We notice they're lined up. We can start to see that if we add these, things won't eliminate or cancel. We notice the y's. So one of the ways to identify they're ready to be canceled is that they almost have matching, well, in fact, they have matching coefficients. We want opposite coefficients. So we're going to adjust the top one by multiplying by a -1. We'll take the bottom one and keep it the same. And now the coefficients are opposites, so that when we add them, we get an answer. And we'll take this and plug it back into either equation. And we'll write our answer as an ordered pair again.